All of you again on my YouTube channel. So, today we are going to discuss the quality of service, that is QoS. So, what is the quality of service? What is the use of it? And all the kind of configuration part we will also simultaneously discuss over here in this session. Simultaneously, we will discuss the some configuration part as well, like how the quality of service works, how many types of traffic we have, and what are the applications which is we can see inside of it. Great. So let's just start. First of all, the introduction of the quality of service. So what is that? A network devices do not really care about the type of traffic they have to forward, which would be like your voice traffic, video traffic, correct? And any of the traffic if you are looking for it. So the network devices doesn't care about it. Okay. Then your switch receive an Ethernet frame for what? To look for the destination MAC address and forward the frame towards the destination. Means the simple process which is we have the control plane and data plane. So after following the control plane and data plane, it will just understand that where we have to send the particular packets or any information. Because of it will find it out the particular MAC address inside of it. Correct? Then the same thing applies to your router. It receives an IP packet, looks for the destination in the routing table, and it forward the packet towards the destination. Correct? That means whenever any packet reaches, whenever any packets wants to send from the source to destination, so they have the particular address for that. So all the time they looks that address to forward the traffic or forward the packets from source to destination. Okay. Now, does the frame of the content of the data plane data form a user downloading the latest song for the Spotify, or it is a important speech traffic from the voice over IP phones? So like what is happening? Let's suppose here are the some PCs which is we have, and it basically wants to request for it is requesting for some kind of the some voice traffic or some it wants to download the some song from the Spotify. Okay, it have the internet connectivity. So what will happen? Let's suppose here are the multiple files running inside the quality of service that is going to identify that what kind of services the users want and how we can define the services. So the routers will identify the particular service which is coming from the PC, and then the routers will give you the reply. Because of between the internet service provider and users, we have routers, correct? So the router will work over there and take the decisions that where we have to forward the traffic regarding this services. Okay. Now what can be the services? Let's suppose here are the some kind of we have some PCs H1, and then we have some IP phones, same as from the another switch as well. So what the PC can do, the PC can request for the data or they can send the some data for this PC. Great. Now the voice the basically IP phones, this IP phones what it will do, let's suppose they just uh, they just wanted to make a call from let's suppose this is the mom and this is your son. So the son wants to talk to the mom, and son will dial the number from this phone, and then what kind of traffic it will share? Then it will share the voice traffic because of it needs the connectivity which would be like voice traffic. So what will happen? This interface IP address would be the default gateway for these two users. Either we have IP phones or either we have the some users. So what will happen? Directly this information will hit out on this interface, and between this the some protocols are working for the communication. Now this forwarding logic is called best effort, or you can say that FIFO, first in first out. Sometimes this can be an issue. Here a quick example, like let's suppose this traffic is very high, so sometimes this data traffic will send it out. If we do not have any large traffic for the voice, so the voice can handle that. But if they have the large traffic, so always it will prefer first. Okay, so it depends upon the traffics as well. Like if they have the lots of data for the sending purposes, so it can send that. Correct. Then it will receive on the another side using your some links, which is they have the speed, like whatever the link you are using, gigabyte ethernet or serial interfaces or fast ethernet. So it will just check the speed of that, and then it will share the data. And between that, if you have the very poor speed, okay, so like if you have very poor speed, so in this case what will happen? In this case, whenever you drop any voice packets in the users on the side of the destination, okay, now if if the receiver is complaining about, you send the lots of messages, but I just receive only one message, that is from hi. But you were asking that hi, like this son is asking, son was saying that hello mother, how are you? Correct. So thus just mother is getting just only hello, not the how are you. So what will happen? Where can be the problem can be exist? The problem can be exist on the link as well. Might be the link speed would be not bad, or the speed quality would be very poor. So might be the data packets will be lost. Okay. Now, what will be the characteristic of the network traffic which is we would have? So, there are four characteristic of the network traffic that we must deal with it. So, what will be? Bandwidth, delay, jitter, and lost. So what is the bandwidth? Everyone knows about it. Okay, is the speed of the link. That's all, right? Means whatever the link you are using, that have the some bandwidth, that have the some speed to share the some data traffic. Okay, then we have delay. This is the time it takes for the packet to get from the source to destination. That means how much time it is going to take to receive any traffic from source to destination, and between this sending data, means from sending to receiving, like one side it is getting to send and another side it is going to receive the data. So that means where the some time is going to take for the sending and receiving the data from the both the side, that is comes with this delay. Okay, where your two things is also gonna be work, that is one way delay and round trip delay. Okay, so what is that? If any things, any packets is getting to check from source to destination, that is called one way delay. The time it takes to get from a source to destination and back is called the round trip delay. That means if your data is sending from here to here and the data is received on that, so that process which is we call it one way delay. And what is a round trip delay? Whenever the data will be sent out from source to destination, and destination is going to give you the reply. So once the reply will receive on this user, then that process which is we called what? Round trip delay. There are different types of delay without going into without going into too much delay. So let me just tell you how many types of delay which is we have. That is processing delay. Okay, we do have queuing delay. Then we have serializing delay. Then we have propagation delay. So what are that? Processing delay. That means it is the time it takes for the devices to perform all tasks. Okay, to perform all tasks required to forward the packets. For example, a router must do a look into the routing table, checks the ARP table, outgoing classes list, and more. Like it depends upon your model, CPU, and particular uh, the link speed and all the things. So
Your
that
voice is not. Jay, your voice is not clear.
It is for everyone or someone else only? It's coming.
Now it's coming. Yes, yes, now it's
Okay.
coming.
Okay, great. So this kind of things. So they do have the four types of delay, that is processing delay, queuing delay, and serializing delay, and propagation delay. So what is the processing delay? The time which is it takes whenever the packets will wants to send from source to destination. So the routing table will look up. The process of uh, the routing table. Sorry, the control plane and data plane traffics, right? So whenever any packets have to send it out from source to destination, so control plane and data plane traffic will be work over there, and then it
Jay,
will
your voice is breaking. Jay, your voice is not. Your voice is breaking. Breaking is.
just give me a minute. Let me. I think there is some problem in the network. Okay. So we were on the processing delay, right? So whenever we were discussing the processing delay, so whenever any packets have to send from source to destination, so always they have to check the routing tables and art table for the sending data from source to destination, because of you will find it out the address inside of these tables. Okay, the source address and destination address you will find it out inside of the routing table and art table. So, totally the CPU utilization is also going to be work on this processing delay, right? So after checking this kind of things, then your outgoing interfaces will look it out by the your data plane traffic, and then your data will receive on the receiver, and they will give you the reply. So after that, what is the another delay which is we have, that is queuing delay. So this amount of the time a packet is waiting in a queue when a interface is congested, the packets will have to wait in the queue before it is transmitted. That means, first of all, there is some kind of waiting time is gonna be happen. Like it will just collect the amount of the packet. It will wait. It will just what it will do. Uh, it will basically consume all the kind of datas inside a queue. You can say that there's a kind of memory where your all the data is going to collect inside of it, and then once your data will be collected, then your interfaces will be coexist for the packet sendings information. Okay, then it will transmit the packet. Then we have serialization delay. So in this time it takes to send all bits of the frame to the physical interfaces for the transmission. That means whatever the data we have, they have some size that would be converted into the bit and byte. Then it will just share it with the others using your physical interfaces for the transmission. Because of we must have the physical connectivity between the source and destination, then you can send the data, right? So the physical connectivity and physical transmission information, who will check that? The serialization delay. Then we have last, that is propagation delay. So in this time it takes for a bit to cross a physical medium. For example, the time it takes for the bit to travel through a 10 miles fabric optic or fiber optic links is a much lower than a time to take to time it takes for a bit to travel using a satellite link. So that means whenever any propagation of the quality of service is going to be happen, that would be your voice traffic, video traffic, or any kind of traffic where it is going to be happen, the propagation delay will work on that. Okay, then we have the different characteristic, that is jitter and loss. So what is jitter? The jitter is a variation of one way delay as a stream of packet in a stream of packets. That means whenever the one way information is going to be sent it using your IP phones, using your PCs. So always your the quality, you can say that, correct? The quality, where your quality is going to check it out inside the jitter. So the jitter will uh, use to get the information regarding your quality of the traffic. Okay, then we have loss. That means once you're let's suppose you are sending the 100 packets, but the receiver is receiving only 95 packets. So the loss and this option will help you out, that how much packet is gonna be lost inside of network using your source and using your any kind of traffic, that would be your voice traffic or video traffic or any kind of traffic. Okay, let's suppose we have the two routers over here, uh, and here we have the some switches. Let me just, then we have the some PCs over here. Okay, so what will happen, let's suppose this one wants to share the some information, that would be your 100 packets of voice traffic. So let's suppose it just make the packets of 100 in a one queue, and it just sends from source to destination. That it know that what is my address, that is 10.1, and where I have to send that, where is 10.2, correct? What is my source MAC address, that is 0A, and what is my destination MAC address, that would be identified inside the RF table. Let's suppose 0B, right? So after checking the all the kind of process, it will share this packets from source to destination. So let's suppose the destination will receive only 95 packet. So 5 packet loss is there, right? Let's suppose 5 packets doesn't receive on this receiver side of this PC. So what will happen? Where you can get the identify this kind of things, you can identify inside the where inside the loss information. Okay, that means how many percentages we have lost. Like if you have ever seen that, whenever you do ping command, let's suppose whenever you do ping command over here on this PC, and you are getting that some reply which is not coming, and you will get the information which is coming from the anywhere. Let me just show you as well the percentage, you will get it also over here, like how much percentage of the data you have received on the receiver side and how much you haven't received it. So let me just try to ping from here. Okay, let me just enable ping, and let's suppose I'm going to ping 70 dot this network. Okay, 70 dot 70 dot 70.1, let's suppose. So what is that? See, the success rate is 100%. That means you are sending the data, that is 5 of 5 datas, and RTP, the round trip minimum, average, maximum. So the time which is you are getting, okay, you are also getting the time. Timeout is 2 seconds, correct? And your success rate is 100%. That means you are easily able to send the data from source to destination, correct? So where you will get the information, like if any data you will lose over here, so you will get the packets information inside the loss of this characteristic in the network traffic. Okay, so that information you will get it over here. Now if I'm talk about traffic types, so with quality of service we can change our network so that certain traffic is preferred over other traffic when it comes to bandwidth, delay, jitter, and loss. So what a kind of traffic type which is we have? We have bandwidth, we have delay, we have jitter, and we have loss. What you need to configure, however, relay depends upon the application that you use. Let's take a closer look like what kind of things you can use it. Basically, there is some application which is we have, okay, and using this some application you can also monitor the size of the traffic as well. Okay, what is the size of it, what is the release and date of that, correct, what is the file name, like if you are sending any iOS file and all the kind of things, so you will get the all the kind of information inside of that. Okay, that means every information you will get it. And if you want to check inside the anything inside the your CLI, so like if you want to check the any version of that any router, so which command you have to use, show version, correct, so that you will get the version information. Let me just show you. See, what is the version, that is 15.5. Releasing software is also there. And what is the software, the file name which is we have, this is that, correct. What is the version, it support like Cisco iOS XE software, this have the some version as well. Extended support release, that means it can support the version of this router series can support maximally this version of that. Okay, and this is for what, when it launch in this year and all the things. Okay, so you will get the all the detailed information. And here is our file name of the flash, like where you can find it out the particular file whenever you will run a command, that is show flash. Okay, see, iOS XC Roman, that means if you want to go inside the any kind of things, wanted to check the uptime and delay timer over here, so you can change it. You can basically, sorry, you can check it. Okay, so like what is my uptime, what is the processor is taking time. Okay, is it power on or not by the ROM, so what is the file name which is we would have. Okay, so you will find it out everything inside of that as well. Okay, now what is that, we have some license information for the module as well, like how many modules that we have attached inside of that. Okay, so you will get the modules information as well, like we do attached on the some kind of ports information or not, so where these kind of information is going to handle inside of your routing table. Okay, if I'll show you the show IP route, so you will get the all the kind of IP address information and MAC address, the port information inside the routing table, where your all the kind of your control plane and data plane will be work over here. Correct. Now we have the some kind of voice and video applications as well. We have multiple application, but uh, we have lots of things like quality of service tools as well, classification and marking as well. Okay, like what kind of particular source and destination and source port, destination port, you will also find it out inside of that. Okay, then we have some IP packets, then we have 802.1q frame, like what is the tag which is it uses. Okay, so we have multiple things, so let's discuss basically the most important part of that, which would be your the particular header information. Okay, so what is that, where you can change, check it, and what kind of things you will get it inside of it. Okay, so let's suppose it sends some IP packet where your where your any kind of things or any kind of source and destinations are gonna be sent over here. So what are that, let's support it let's suppose it send a particular IP packet from source to destination, and inside the IP packet you will get the version length, quality of service bytes, toss field, which is we call it. Okay, type of service, right, then we have length, ID, offset value, TTL, port, FCS port, source destination port, and then we have data. So these kind of information it sends. Then we have some tag, correct. So inside the tag, which is what kind of 802.1q frame tag, let's suppose it is sending by the switch. So the tag which is it is generating, and inside the tag it will just check the what is the ether type. That means what is the your the 802.1q ether type you are using. Okay, then we have some priority and then cfi field and then VLAN identifier. Because of if I'm using the switch, so to send any information that would be regarding IP traffic or any kind of voice traffic. So where you can identify, you must have to aware about the tags 802.1q frame tag. Okay. So whenever you will just get identify about this, then the IP header will be walk over there, and then the access control list. Basically, the access control list will give you the authority uh, to deny the particular traffic. You can deny that particular traffic, or you can allow the traffic according to your requirement. Correct. Now let's jump on this part of that. That is why do we need quality of service on LAN switches. Okay, so the quality of service in our LAN switches is often misunderstood. Every now and then people ask me like why we need it, since like we have multiple enough bandwidth to send the information from source to destination, then why we need it. If we don't have enough bandwidth, it is easier to add bandwidth, then our LAN links will be work properly. Then our WAN links will be work. If you use any real time application like voice over IP or any kind of video traffic, then you should think about the implementing of quality of service in our network devices. So let's suppose here are the some users, and here is the switch one, or sorry, server one. So the server one have the all the kind of authority. Like what we do, simply we request for some information from server, and the server will give you the authority. Like if the server have any kind of information, so we request anything from the server, and the server will give you the reply for that. Correct. Now what it will do, let's suppose the PCs send the some kind of traffic load of the 100 mbps. Okay, so when the server will receive this kind of traffic, let's suppose the server needs to share the information of you know the 1 GB or more than that. So what it will do, it will just send the information, and what it will do till receiving the information, let me just explain it over here so then you can understand. Okay, let me just hang on a second. So let's suppose um, here is our switch, here is our router, and then here we have, let's suppose, Google server. Okay, then here we have the some PCs, or you can say that users. So what the user will do, let's suppose user is going to send the some information of 100 MB. Okay, but the server support minimum requirement which is it have to send, that is 1 GB. Okay, this have the link speed as well, that is it is using the gigabyte ethernet link. Okay, so it have the limitation to share the traffic of 1 GB per second of more than that as well. Okay, because of you are using gigabyte ethernet port. Now it is going to send the some information of 100 MB, the information from going to out from this PC, and then over here the buffer memory, that would be like a bucket, right? So whenever you said any kind of water from here, let's suppose this is our water line, and you are sending some water of 100 400 liters. Okay, You are sending the water from source to destination, that would be 400 liters. But this buffer memory have the capability that is minimum 600 liters. Okay, so what will happen? This buffer memory will accept that the all the where the all the kind of water is coming from. It will accept, and then till this buffer memory will full, then the other information will be transmitted. That means, first of all, we must have to fill the buffer memory, or you can say that the client requirement. Then the other will be receive the particular things from the source to destination. That would be like this. So let's suppose this is buffer memory and it is sending the traffic load of 100 MB per second. Now, the switch 1 and switch 2 having like they are using the gigabyte ethernet link inside of that, and this is also the capability it have, that is gigabyte. But this is using fast ethernet. Okay, this is using what? Fast ethernet. So the computer is sending the 400 MB per second of the traffic towards the server, right? Of course, the fastest running only the bandwidth that it is having the 100 per second, 100 MB per second, but it have more than that, like 1 GB per second or more than that. Okay, so what will happen? This is not able to handle the traffic which is coming from that. Okay, so for that, what we can do, we can just add a buffer memory where your all the kind of data is going to collect, and then according to the requirement of this link speed, this buffer memory will take place, and then it will decide that what kind of speed that our server support, and then it will just manipulate the particular speed from here, and then the data will be sent it out. Okay, let's suppose here are the multiple traffic switches we have. Okay, now every switches is forwarding the 70 MB per second of the speed, and it is using the buffer memory till the buffer memory will be full. Then your other transmission will be done. Like, it will just accept the request which is coming from these PCs. Okay, and then it will take decision that what I have to do. So once the buffer memory will be full, then this will send it out the traffic towards the servers and all. Okay, so this is exactly how this quality of service works, and this is why we need it to handle the information of the particular voice traffic, video traffic, or any kind of signaling as well. Okay, so this is the quality of service uses. This is the use of quality of service. If I'm talk about the traffic policy, like what would be the traffic policy which is its support. Uh, so we have the multiple traffic policy as well, right? So introduction to the policy, if I'm talk about, when you get a subscription from an internet service provider, let's suppose you just bought the connection from the fiber optic connection. Okay, so you will pay for the like the particular cost for that. Like, if you purchase the 100 MB per second of the speed from the any service provider, so you have to basically pay some cost, right? That would be your anything, correct? So what will happen? The fiber connection, however, it capable to send the traffic at a much higher uh, bit rate. For the example, 100 MB per second or whatever it is. Okay, so what will happen? You know that what is my the particular speed which is I bought it. Okay, so what will happen? The information is also going to send it out once the traffic will be drop, or once the traffic will be exchanging between source to destination. Okay, that means you must have to aware about what is the speed which is I'm using, and what kind of service provider services it is providing it. Okay, so we must have to aware about the policies, like the the multiple links I'm using or single links I'm using, right? What kind of what kind of information which is I'm going to pay for it. So everything you must have to aware about that. Like once the token will be filled out inside the bucket, then your bucket will be sent it out toward the other bucket, and then vested token will be also there. So that means you must aware, you must have to aware about like how exactly our buckets and the requirement is going to fulfill. Okay, so we must have to fulfill the requirement according to the source to destination. Like if the source is having the requirement of, let's suppose 5 users, or let's suppose voice traffic. Now, what you are saying that I know that what kind of traffic switches it needs, but I'm sending the 4 packets for voice traffic, but I'm not sending the 9 other traffics which would be regarding the voice. So what will happen? This will receive it, but once you will send the 9 traffic inside this bucket have the limitation, that is it can support the 5 voice traffic, but you have the another traffic would be 9. So you will send it out, like you will not stop to send any information inside of that, but this buffer memory will, once the buffer memory will be filled, so what you can do, like then your the data is going to flush it out, means this is going to flood inside the another bucket, you can say that, or another buffer memory. So there will be the multiple policies, like which is we called it uh, 3 color polyser. Okay, where your multiple buffer memories are gonna be work according to the requirement. There will be the multiple buffer memory is going to be work to handle the particular traffic which is coming from source. That's all. Okay, that means only understand this, that is we must have to aware about the buffer memory. Okay, the capability of the buffer memory, the bandwidth of the link which is I'm using from which is I'm using to send the data from source to destination. So we must have to aware about that kind of things. Okay, so let's discuss the another traffic, which is we have what, the another configuration part of this. Okay, so like how we can configure the policy configuration which is we have on the quality of service. Okay, how we can configure that, what kind of process we which is we have to follow. Guys, am I audible clearly?
Yes, yes. Yes, yes.
Okay, so what kind of configuration part which is we have to do and how we can do that. So between the two routers we will configure the quality of service, and then we will discuss like any kind of traffic which is we must have to send, like ICMP traffic, TCP traffic. Okay, we do have UDP traffic. So all the kind of traffic which is we have, we will do configuration regarding this. Okay, so let me quickly turn on the one of the configuration Eve, and I'll just do the configuration as well of the quality of service, and then we will do the configuration part out as well. Okay, I'll just assign you the task regarding this quality of service as well. Okay, but before this let me just configure that. Okay, so fine, let me just which image is it, 2010.6, right? Just 172 dot images. uh, Admin, So let me quickly do the configuration between the two routers. Let me take it quickly. Two routers, let me click it over here. Click on add nodes, take the routers, Cisco, click on save. Again, click on one more router, take it, and then save. So let me just quickly connect that together as well using your Ethernet cable, and let me turn on these devices now. Okay, now it is started. So between the router number 7 and 8, we are going to configure the quality of service over here. And what are the configurations part which is we need to do? We will follow the same process for that. But before that, we will configure the IP address which is mentioned in that. What so 192.168.12.1 on this interface and 12.2 on this interface. Let me quickly take the console of router number 7 and router number 8. Working. Okay, I think it will take time. Take the router number 8 console as well. And yes. So on this router number 7, we have to configure the Ethernet 0/0. IP address would be 192.168.12.1. Okay, so go on enable config T and then Ethernet 0/0 IP address 192.168.12.1. Simple configuration we are going to do. Okay, so let's configure the IP on the another router as well. Let it come up. Enable conf e interface Ethernet 0/0. IP address would be 192.168.12.2.0. Okay, and do no shutdown. Write the configuration as well, like if you have any problem on that, so we can just turn on the interfaces as well. Okay, so let's configure first of all on the router number this, that is class map, which is we have to create the some class map services. Okay, so class map, what is that? What you want, you can give the any kind of traffic as well, like you can match all as well, like if you want the class map and you wanted to add any kind of word, so you can add it, otherwise I can give the any word for here. Okay, and what we want, that is match protocol, which kind of protocol we can match it over here. Let me show you. We have multiple protocols which is we can map it over here. See, these kind of services we can map it. Okay, with the quality of service, you can see the lots of services we have, guys. Okay, like till alphabet A to Z, you will just see the like all the kind of configuration. See, we have multiple things, but what we are going to use, that is ICMP traffic, because of whenever anyone needs to, send in, when anyone needs to send any information, so always the ICMP traffic will be work. What is that? ICMP. Okay, and then after that, this is the correct command. So what we want the match protocol. What kind of protocol we are going to match? That is ICMP. So we have two things inside of that, which would be ICMP echo and ICMP echo request and ICMP echo reply. So regarding the this policy map, what kind of things which is we can map it inside of that, we will also discuss. Okay, So after configuring the protocol, like after matching the protocol inside of that, what we can do, let me just let it map. Okay, see, this is by default directly connected, so we don't need to configure any routing protocol over here. Okay, directly we are going to configure the quality of service, that's all. If we do not have any kind of things inside of it, like not directly connected, so we must have to first of all make the connectivity between the source to destination, and then we can configure the quality of service on that. Okay, let it complete. Let it. Okay, my phone is not going to charge. Sometimes it takes time to run the particular service over here, right? That is why it is taking time, a bit of time, that's all. If we will perform on the CCI lab, so it will work fine because of they have the higher configuration RAM and the devices as well, so that would be work fine. Okay, but we don't want, so that we can just add it over here only. Come on, and I'm just pressing any alphabet as well, if it will work. It takes time, but yes, like after matching the policy, we have to like take the action after that. Okay, now it is inside of that. So this is what class map policy, right? We are right now inside of class map policy. Okay, so what we can do, what we can enable the policy, that is we have to first of all go back, take the exit. Then what we have to do, we have to run a command, that is policy map, and then we can just add any kind of number over here, right? Let's suppose single, we are going to use single router, router space, it doesn't support space. Okay, after that what we have to do, we have to define the class as well. So what class I have just chosen, ICMP, right? That is the word which is I have used in the previously. If I'll show you, after configuration of IP, what is the use, what the command which is we use? See, so history. Yeah. Type so history. So we can just use that as well. Otherwise, you can just see the particular but you have to remember the name. Always you must have to. Okay, because of whenever you are going to map the particular policy with this, you must have to remember the name. Okay. So policy, we have to define the policy number. You can define. Otherwise, you have the some other criterias as well, like you can define the rate as well, specific policy rate as well you can define. That would be like 80% and this kind of things. Okay, we have committed information rate as well, like CIR, which is we called it, but we will give the some rate, let's suppose 12,000. Okay, so we just define the policy rate, the number over here, and after that, what we have to do, we have to confirm about what? About the action, not the color. About the action, what the action it will do, that is transmit. Okay, we have multiple action as well, which is we can use it for that. We can take action of drop. We can take the action of transmit, set quality of service transmit as well. We can take it, set tunnel transmit as well. We can, if you have using the tunnel interfaces, so you can use that as well, but I'm using the transmit only. Okay, now what can we can do, we can after that exceeded action you can take it for that particular things, which would be dropped. Like after taking confirmation of the transmit, if they are not able to find any traffic, then in this case what they can do, they can take the action which is drop exceeded action. That means whenever any traffic is going to exceeded more than this policy, like this number of the policy. Let's suppose I just define the policy that they can match maximally 12,000 policies inside of that. But let's suppose might be because of there will be the multiple users, they may be they may be just request for the multiple the services in the same time. So what they can do, they can just request the datas request for the data for the types of services datas from the server. So the server will not identify basically where it is coming from, because of they just get confused. Like if they have the requirement that is high, the high requirement. So in this case, after checking the 12,000 of the request, this will take the exceeded action, that would be drop. So we just drop the action after that. Okay, what we can drop, let me just, so we have to just get back one step back, and then we have to define the policy. Okay, what is the policy? That is, we have said that is 12,000, correct? Then confirm action, we also have to define first of all the confirm action. What would be the confirm action? First of all, the transmit the data, and then exceeded action. What is the exceeded action which is we have? That is drop. Okay, so you can just set this kind of action inside of that, and for which interface you have to define the interfaces as well. Okay, so go on the interface, that is interface ethernet 0/0, because of we are using the interface ethernet 0/0 only. Then what we have to do, we have to define the service policy. What is that? Input, what we have done, single router, right? That is the name which is we have defined for the single router. Okay, so after defining this, then it will just transmit the data. And if I'll show you the particular times for that, let's suppose I'm going to reach out from here, do ping, and that is 192.168.12.2, let's suppose, and a repeat packet I'm going to send it, let's suppose 1000. Okay, first packet it will get drop, then after getting the second packet it will take drop. See the action, what action we have defined. First of all, the exceeded action, it is taking what, it is taking exceeded action. Yeah, are you seeing that? Every exceeded action it is taking, like whenever the the request has been exceeded, so it will take the action, that is drop. Okay, that means after limited of this action which is it needs, after that it is dropping the packet. Okay, so this is how you can take the action, like if any users want, so you can take the decision as well. That is, if any one user is going to exceed the limit, so you can take the action on the particular user as well, that is the drop. Like you can define the particular user inside that, not exactly here, over here on this interface. So you can define the particular user where it is coming from. Like we know that how many users that is we have created inside of this interface. Like if we have the multiple interfaces, so you can define the actions on these interfaces as well. Okay, so we know that how many user has been created on this using this link, how many users is created using this link or any other links if you have. So you can take the particular decisions on the particular user as well over here. Okay, so this is how you can use the service policy and quality of service over here. I hope guys, I know that it is a bit of tough to understand, but yes, this is how we can identify the traffic, and we can deny or we can just get permitted from the particular user. Any of you have any doubt? If you want to check the policy, so you can just run this command show policy map. Then let me just show you on this router number 8. That is do show policy, like not here exactly, and show policy map and what you can define the particular interface as well. Okay, so like interface ethernet 0/0, we have defined this for this user only, this interface. So what you will see, mm, 9900 999 packet it sends, the size which it have, that is this. How much time it takes? 5 minutes, right? And bytes per second which is it using, that is 2000 byte per second. And drop rate which is it have, right now there is no drop. Which protocol it uses, what protocol we match inside of that, that is ICMP, correct? Then we have a policy base second route as well. We have confirmed packet which is this. Okay, size of that packet was this. The action which is it confirmed, that is transmit. For the 71 packet it takes the action which is drop. So confirmed is 1000 bytes per second. Executed, that is right now there is no any kind of exited. It is getting match any prefixes which is coming from the ICMP, right? And then match 5 minute rate which is it is taking for the offer, that is 5 minutes. Okay, so this is exactly uh, the basically your protocol is gonna be work using this kind of quality of service configuration. Okay, if you want to check the quality of service session policy over here, so you can check the session. Okay, like let me if I show you policy map session. Okay, which session you have to give the input or output session, what you want. Let's suppose output session, we want output session. Okay, so there is no any kind of output because of we are giving just the and only what only just ICMP protocol which is we are using. This is for the transmitting packet which is I'm sending it. Okay, so there is no any kind of the session which is has been mapped inside of that. But yes, if you have the session, if you have created the session, so definitely you can check it for the particular policy of the quality of service. Okay, if you want to check the control plane, what if you want to check the control plane, so you can check the control plane all. Okay, so there is no any IP address or any routing protocol which is we are using. That is because of these links are directly connected. So for the directly connected, we will never see that. Okay, I'll just also share this PDF to you as well, so you can do the configurations as you want. Okay, guys, I'll do one thing. Let me share this content with you so that you can take the action on that, and you can just give me a minute. Where is the quality of service? Here is that. Uh, the PDF was the configuration part, right? Traffic configuration, right? Traffic shipping, not this. I'll just share hold. Okay. So that PDF name is that is this of your quality of service policy configuration. Okay, policy configuration. So just check it out and do the configuration as well. Okay, just check it out. I hope guys you don't have any doubt regarding this, but you must have to work on the practical part of this because of see for the traffic base you must have to aware about which protocol you are going to use inside of that, correct? So that means you must have to aware about your the particular protocol which is you are gonna be use, correct? Any doubt you have? Not exactly, not right now. Guys, are you sleeping?
Yeah, actually, I wanted to know that how it is considering that suppose you are reaching that the policy map you said at around 12,000.
Mm-hmm.
So how it is calculating that when it need to drop because the traffic is getting the exit value or reaching the exit value
See, whenever you wanted
because
to.
the output
Yes,
we are seeing
yes.
that it is working, that is confirmed, but
Okay.
how it is taking into the consideration of the fact that we are setting the policy map and it is set around 12,000. So what criteria it is using to check that the traffic is reach at the defined level.
Particular protocol which is VMAT.
The protocol I understand, but why it is dropping? You see the layer of ping after certain that is very consistent. After 20 ping, there is drop. After 20 ping,
Mhm.
ping this is symmetrical like that. The 20
Yes,
ping drop, 20
not the
ping drop, 20 ping.
not the symmetrically. You will let me show you as well. Sometimes you will get distraction as well. Like see over here, you can count as well. Like after this, what exactly you're getting this? Like sometimes it is
You see
sending more
the,
packets,
this
sometimes
pattern
it
is
is not.
looking symmetrical drop.
Yes. So what is
So
happening?
we
See,
can consider this as a we have set this policy map because we are getting the symmetrical drop.
yes. See percentage rate you can see over here, right? What is the use of that? Like why it is 92% only? Because of whenever we just map the traffic which would be protocol, we map the protocol which is ICMP. So once the ICMP echo request will be worked, so first packet will going to drop, second packet, third packet, fourth packet, fifth packet, then these packets will be received. Because of in the first packet, what is happening? Did you just have you just any idea about the packet flow, like why the first packet is going to drop if you are going to if you want to send any information from source to destination? So that is the thing, right? Because of the we map the protocol which is ICMP, and for this ICMP we just take the two action, that is permit and drop. So why it is going to take the first of all this drop whenever the first packet it will send. So there your first drop is going to consider inside that, and rest of other will consider inside your permit statement, which is you have given inside the policy map. Let me just let me show you. Um, See, we just enable the service policy input, that is single router. So inside the single router, what we have done, let me just show you the whole configuration. uh, Show run by section policy. See, we just map the what? we just map the class which is ICMP, and then we have take the two action, that is conform action which is transmit, and the exceeded action which is drop. Then we just configure the service policy input, that is that particular policy map I just called inside of this the policy CIR number. Okay, why? Because of whatever the whatever the protocol we just configured, we know that we just configure the ICMP inside of this, but where we have to map this particular protocol, whenever we just define the particular action, then we have to define the particular service policy input, the single router, that name, which is we just define the class inside of that, the particular protocol class, right? So this is how exactly the two actions is gonna be work over here, that is drop and transmit. So after every, whenever the first packet is going to send, the first packet always going to drop, then second information which is permit, so always then permit is going to receive on the another side of it. Got the point?
Hmm.
So that is the main thing, because of we just map the particular protocol, whole protocol inside of that, you know. And whenever you just try to ping, what we are doing over here, we are just reaching out, well, like we just use the ping command. We do Did we use any other command over here? That means we just send the thousands packet over here. Okay, so the how the thousands packet is going to send it out, after every some packets it is going to drop the particular message, because of the two actions
Uh,
which is we have formed from the destination side.
so you mean we try to ping the 100 packet, then the same thing will happen.
Yes, it will also happen the same thing with that as well. If I'll show you, let me just uh do ping for 192 168 and 12.2, right? And then repeat packet. How many packets you want to send? 100.
100.
See, same action it will take. Okay, if you'll take the
So here the
minimum,
first is
yeah, minimum
here
it
the first is
first is
the
going to
first packet
send.
is allowed.
Yes, for the first is allowed, but the another is again going to drop because of the action. The first action, it just take the performance which is permit. Then second action, that is drop. Whenever the limit has been exceeded, the limit will be exceeded. Then that is drop. Whenever the limit will be exceeded, whatever it will take the permission, that is policy we have set, that is drop. So it is dropping the packet. Then again it send the packet, then it drop the packet. Then it again
So
it
try
send the
try
packet, then it drop.
try using the 5 only.
It will goes, because of we have see, it will goes even though you're 10 as well. Might be 9 or 10. No, I think 10 will be, yes. But if you want to go more than that, like 15 and all, so like because of see this, so that means where the some limitation it is having, right? It have the some limitation, so using this limitation, it just check the permission according to the buffer, not the exactly your router and all. It takes the buffer limitation, because of what we have done, like whenever the buffer memory will be full, then it will send it out. Whenever the buffer memory will be not sent, will be not full, then it will just what it will do, it will just read the packet, it will collect the packet, then it will just do that. Correct?
Okay. Okay.
So I hope you understand this. You must have to do the practical as well. Okay, I'll also upload this on the YouTube channel.